So number 6, equilibrium index of an index is such a blah blah blah. So I'm basically, what I'm doing here is I'm basically finding the middle element that balances the left part and the right part. So the naive approach would have been iterating through all the possible arrays, but then apparently there's an easier way to do this. So I'm going to write public int equilibrium r, no, int r, int array of r. So first I'm going to do for int I equals 0, I dot r dot length I plus plus. So int sum is 0, and sum plus equals r I, and I will have all the sum that is in the array. So to find the equilibrium point, what I'm doing is, so I'm starting from the left side, and I'm going to subtract the value that I'm indexing, which I picked as an equilibrium, and I'm going to subtract that value from the left side. So I'm going to have the int left sum as 0, because when you start, I don't have anything that's left to my array, I mean the equilibrium. So sum is sum minus r I. So now this is the right sum. Yeah, and if left sum is equal to sum, return I. And I also have to add, for the next iteration, I have to add the left sum, our current index point, which I took out as an equilibrium point, but at next index, this will be the next it's going to be part of the left sum, and then the index that you're looking at is going to be your equilibrium point, and it's going to be taken from the right sum. So if this line of code didn't just finished executing without hitting this return point, that means there is no equilibrium point. So I'm going to return negative 1 as a sign that there exists no equilibrium.